So you've got your business apps running over here, storing transactional data in a Postgres database. Wouldn't it be great if you could use Postgres native replication features to have that data automatically make it over here to Snowflake, where you can analyze it in the rest of your warehouse? Well, today I'm going to show you a really quick and easy way to get it set up securely. It'll take you less than 15 minutes to have it running in a production environment. Before we get into that, I think it's worth discussing what some of the other options are for connecting two private data systems and some of the challenges you have in doing that, and why Ockam is the best approach. So what are the common options we're looking at? Well, let's start with Private Link and Secure Connect. These are fantastic if you're able to use them. Private Link on Azure and AWS, Secure Connect on GCP. They provide a point-to-point connection from one service in this network here to another service in that network over there. The problem is, though, they can be difficult to set up, not technically necessarily, but organizationally. We hear that a lot from customers who have a hard time getting the team to mobilize the network boundary changes required to make a system like that work. The other challenge is you have to be on the same cloud, so you can do an AWS to AWS connection, but it doesn't work if you're multi-cloud or hybrid or on-prem. These are just not options if you're running data centers yourself. What else do we have? VPC peering, a network level connection that allows the network over here to talk to a network over there. Now, problem with this is you're opening up a very big door between these two networks, and you then need to put route tables and config rules and other things in place to try and close that big door that you've opened down to just the two things that wanted to talk. That's the strength of Private Link, is it was just those two things. Network level connections give you a big door, and then you try and put rules in place to close it back down to the thing that you actually wanted to happen. And VPNs are another solution that I'd put into that bucket, where you're basically doing a network level connection. You're taking a network here, a network there, trying to make them look like one network, and then locking it down so that's not actually what happens. You end up with just the two services talking to each other, not two entire networks. Now, if you're on Snowflake, those two options, understandably, aren't actually options for you. Snowflake don't allow you to do that. They recommend you use Private Link for the reasons we suggested that it was a great solution to begin with. So what's left? A publicly addressable address. The whole reason we put things in private networks in the first place is because we don't want them addressable to the public internet. We're compromising a big security stance here by making these systems available on the public internet in the first place. And IP allow lists, which is basically pretty much putting something on the public internet but trying to close it down to only be accessible from one IP address. The problem with that, though, is even when you think you're only allowing one IP address, that's not one service on the other end. What typically happens at the other end of that connection is that it's a NAT gateway or a proxy or something that is set up to share that IP address across many systems for availability, and lots of good reasons why a company would do that. But it's not one system. You're back to ultimately allowing the entirety of a remote network into your network. That's not what you want. You wanted a service-to-service, a point-to-point connection. So let's talk about how Ockam is different. Like Secure Connect and Private Link, Ockam enables you to create a private point-to-point connection between just two systems, not two entire networks, just the systems that need to communicate with each other. What's more, this works across any cloud, hybrid, on-prem. It will work wherever you need it to work, with any data store or system. Furthermore, the Ockam protocol ensures that this private connection is secure. It is end-to-end encrypted. The Ockam protocol also takes care of a whole bunch of complicated things that make it almost impossible to mess these things up and ensure that your systems are secure by design. That includes the way we handle enrollment tickets and the way that nodes register with a project authority, the way you're able to provide cryptographically attestable attributes to your nodes, and then use those attributes to apply policy-based access controls to further restrict what nodes can communicate with each other. Each node generates its own keys so that we never handle the encryption keys for you. And that also means every node and every connection is mutually authenticated. So you have strong cryptographic guarantees about the integrity and authenticity of the data that travels over your connection. The Ockam protocol also includes automatic and regular rotation of the encryption keys, further reducing the risk with all of your private connections. Ockam is the most secure way to connect any two private systems across any network topology. So it's time to get started moving that data from Postgres to Snowflake. To install the Ockam pull from Postgres connector, go to the Snowflake marketplace and search Ockam pull from Postgres. You'll see this marketplace listing. Click the listing and then click the Get button. Click the Get button again, and now the app is installing. The app successfully installed. We can configure it. Click the Configure button. The app requires certain privileges to be able to access your warehouse, so grant those privileges automatically, and then click Launch App. You're now presented with a welcome screen and a list of steps you need to complete to finish the configuration. In this next step, I'm going to show you how to sign up for an Ockam account, download Ockam command, and set yourself up as an administrator for your first Ockam project. If you've already done that before though, you can skip this step and get straight to setting up your first node. You'll need an Ockam account to get started. So go to ockam.io, sign up, and it will give you instructions on how to download Ockam command. You'll see here we're running the install command, it's installing Ockam, and we'll use that to generate the tickets that will connect our services. So here we are, Ockam has been installed. We're going to enroll our local machine as an administrator, and that will allow us to generate the tickets we require. So we've copied the code to the clipboard, continue, we'll confirm the details, and we're all set. If we switch back to the terminal, you'll see that it's signed in and it has activated my local machine. Okay, it's found a project. If you don't have a project already, we'll set one up for you automatically. Now, before we complete this next step, I'm working from the assumption that you already have a Postgres database running an RDS that you want to connect to. If you don't, or you don't want to connect to the one that you have running, I suggest you pause the video now and quickly spin up a test or dev environment that you can test with, and then resume the video once that's complete. Now that you have a running RDS instance, we need to change one of the configuration parameters to enable log replication. So I'm going to modify this database here called demo, but first we need to create a new parameter group. So create a parameter group, give it a name, RDS replication, description, so that at some point in the future you know what this group is actually for. Okay, enables replication for Postgres. This is for PostgreSQL. And then you need to choose the group family, which if you have a look, it's just the various version numbers. You need to actually specify one so they know what parameters are appropriate. So we're running the latest version, so choose 16. Okay, let's create an RDS replication. Now we need to edit it. And the parameter we're looking for is rds.logical replication. Cool. Need to set that to 1 and then save those changes. Okay, now that that's done, we'll go back to our database and we need to modify the database and scroll down to additional configuration. Oh, not this additional configuration. There's one further down. There we go. Additional configuration. Database options, we need to change our parameter group to the RDS replication one that we just created. Continue, and you need to make a decision that's appropriate for you. I want to apply this immediately though, so we'll modify the database right now. Okay. I'll chop out a video here, but this will take a few minutes. Okay, that change has been applied. I also needed to reboot this for it to take effect. So I'm going to reboot this instance. Again, this will take a couple of minutes to complete. I'm going to skip ahead in the video so you don't have to wait. Okay, and that's available. Now we're ready to go and make the changes required on our actual tables. Okay, so the parameter's been changed, RDS is rebooted, it's available again. We now need to modify our customers table, so just show you what that looks like. This is our customer table. This is the schema for it. Okay, not that important just now, we'll use that later though. We need to alter the table, customers, and set the replica identity to full. Run that, and our job here is done. Our Postgres table replication needs a matching table on the Snowflake side with the same schema. So we're going to create that now. ID int, not null, name that's a varchar, an email that's a varchar, and that's it. At each end of a secure point-to-point connection is an Ockam node, and we're going to set up the first of those for you right now. We're going to run an Ockam node right next to our RDS instance, and any packets that come through are going to be forwarded via the TCP outlet on that node to our Postgres RDS instance. Let's show you how to do that. Once we have a private RDS instance that we wish to connect to, it's time to set up an Ockam node that will serve as an outlet and allow other connections to communicate with that Postgres database. So go to the AWS Marketplace and search for Ockam Postgres. You'll find this marketplace listing. Click on it, and then click Continue to subscribe. Then we click Continue to configuration. Okay, and on this screen, ensure you choose the region where your RDS instance is running. In my scenario, it's Northern California, so we're choosing US West California. Click Continue to launch. And then the launch button. This will start a CloudFormation template that will run us through setting up a managed node for you. Just accept the defaults on this page. All right, let's give this stack a name. It will appear in various places within the Amazon UI, and it will make it easier for it to decommission all these resources if we don't need them later. So Postgres demo, I choose the VPC where my RDS instance is running, and then I choose the subnet where one of those instances is available. And MX8 large is too big for my needs. I'm dropping it down to just a large. And now we need to provide an enrollment ticket. This enrollment ticket is what allows our node to register with our Ockam project. So we'll switch to a terminal and we'll generate that ticket now. Okay, so I'm generating a new ticket for my project. I'm saying this ticket is only allowed to be used once and it must be used within 24 hours. We're also putting an attribute on whatever node registers using this ticket, and that attribute will be Postgres. And we've also given it the shorthand form here to say it is permitted to create a relay called Postgres. The output of that command we then pipe into a file called postgres.ticket. I'm then going to copy that file to my clipboard and we'll paste it into the CloudFormation configuration screen. Now need to provide the endpoint to access the RDS instance. You'll find that on the client information page within your RDS screen for that particular resource. And the JSON node configuration that will pass the Ockam command when it starts up. This instructs the node to create a relay named Postgres, to create a TCP outlet that will forward to the database endpoint we've just specified in the field above that, and to only allow access to that endpoint to a node that has the attribute Snowflake. You can either copy these values here from this video, or if you look at our docs page for this scenario, you'll see a template that you can use. Click Next. I'm fine with all the defaults on this page. I acknowledge that it create resources and submit. A stack creation process will start. Within a few minutes, this node will be up and running and created an outlet that allows us to connect to our RDS database. Now, AWS has a very strong posture when it comes to the security of your data, rightly so. That means though that the RDS instance and the Ockam node that we've just created via the marketplace will not be allowed to communicate with each other just yet. The security groups will lock down access to that RDS instance. So we need to go and make a change to enable the communication to flow. So to do that, go to the RDS instance, scroll down in the connectivity and security section, and you'll see this button here, set up EC2 connection. Choose the appropriate instance from the drop-down box. Here's the Postgres demo instance that we spun up before. Click Continue. And then scroll to the bottom of the page and complete the setup. That'll take only a few seconds to complete. And now that node will be able to communicate with our RDS instance. Now it's time to complete the Snowflake side of this setup. We're going to run an Ockam node in a container on Snowflake, register it with our Ockam project, and it's going to be able to establish a point-to-point connection with the node that's running over near RDS. Now the first thing we need to provide in the configuration screen is an enrollment ticket. This ticket lets the node that's running in Snowflake register with our Ockam project. So to create one of those tickets, we're going to switch to a terminal and run the Ockam project ticket command. Here you can see I'm providing a few different arguments. I'm providing a usage count of 1, which means that this is a single use ticket. It cannot be redeemed a second time. And I'm saying that the ticket will expire within 2 hours. So if it's not redeemed within those 2 hours, it will also not be redeemable. This helps strengthen our security posture, which means it's very difficult for tickets to be mishandled and used in ways we didn't intend. We're also specifying a cryptographically attestable attribute of Snowflake. This means that whatever node registers with this ticket will be given the attribute Snowflake. Other nodes can then use this attribute as an input to make policy-based access control decisions. The output of this command we pipe to a file called snowflake.ticket. I'm then going to copy that to my clipboard. And we'll switch back and we'll paste it in. Click Next. We need to grant some privileges. We need to allow egress to reach our Ockam project node. So we'll allow that and click Connect. We also need to give the app access to our Postgres database. So flick that toggle and provide your Postgres username and password. And then the final option on this screen is to allow us access to the tables locally that we will store the data in. So we'll select the database, the schema, and the table, or tables. In this case, it's just the one, the customers table, and we're done. We'll save that and continue to the next screen. Now we need to provide the name of the database within Postgres, and then we need to provide a mapping between the Snowflake table name and the table name in Postgres. Now the Snowflake table name here isn't actually a table name, I should be more specific, it's a reference. Snowflake apps don't have access to the actual table, instead we get an identifier. And so we've been able to provide this because the table was selected on the previous screen. There's some notes here on how you can find the correct table name reference if you need to look it up manually. But here we'll take the one that's provided. We'll say the Postgres table name is the public schema.customers. That all looks fine. Let's click Next. And now we wait for the app to start. I'll skip ahead so we can see what it looks like when it's finished. Okay, the application is up and running. We've got the green check mark here telling us that it's running, that the Ockam portal is up and running, and that the connector to Postgres is also running. And now, if everything is working well, our change data capture records from Postgres will be streaming across our Ockam connection and into our Snowflake database. So far, we've enabled logical replication on our RDS instance, turned that replication on for the customers table that we wanted to sync. We're now syncing that data across to Snowflake over a private point-to-point and secure connection, and we haven't had to expose any of our systems to the public internet. All that's left now is to show you it in action. So let's show you that this works. So from a Snowflake worksheet, I'm going to select from the customers table and show that currently that table has no data in it at all. We're then going to switch to a Postgres client, and I'm going to insert a row into the customers table. ID name email, values of 1, Alice Smith and Alice at Ockam. Run that, it's inserted. We'll check that that record is there just to prove it. We'll switch back to the Snowflake worksheet. And you can see that the customer has been entered into that table too. We'll now make a change to that record. So let's update customers. Add a middle name for Alice. And we'll switch back, run the query, and you'll see that change has been replicated in real time too. Now, if you remove all the explanation and commentary from me about what we've been doing today, and the time spent waiting for containers to start up, in just a couple of minutes of configuration, we've been able to establish a point-to-point connection between two private systems. Our Snowflake warehouse is able to connect to another data source. We haven't connected two networks, we haven't exposed any of our services to the public internet, we're not having to manage IP allow lists. It's a point-to-point connection, much like Private Link or Secure Connect. But it works across any cloud, on-prem, or any kind of hybrid environment. Furthermore, it's a secure connection because the communication is end-to-end encrypted, with each node generating its own encryption keys and sharing those in a way that means Ockam never has access to those keys. And the keys are automatically and regularly rotated for you too. Ockam is the most secure way to connect any private systems. Use it today. If you haven't been following along, please, what are you waiting for? We'd love to hear your feedback. For more information, check out our homepage, www.ockam.io.